Ladies and gentlemen, good morning and very welcome to Nobel Forum this morning for the announcement of this year's Nobel Prize in Physiology or Medicine. I will first read the announcement in Swedish, followed by English, and after that we will have some time for presentation of some background and of course to open up for questions. So I'll start in Swedish. Nobelförsamlingen vid the Nobel Assembly at Karolinska Institutet has today decided to award the 2019 Nobel Prize in Physiology or Medicine jointly to William Kaelin, Sir Peter Ratcliffe, and Greg Semenza for their discoveries of how cells sense and adapt to oxygen availability. Here we have the three happy laureates. To the left, Greg Semenza. He was born in 1956 in New York. He performed his prize-winning studies at Johns Hopkins University in Baltimore, where he's still active.
Semenza and others showed that HIF was present in almost all cells, and at this point HIF was potentially a key regulator of oxygen responsiveness. Further work by a number of groups showed that HIF was constantly made by cells. Called normoxia, it was constantly destroyed by proteasomal degradation. At the time of the cloning of HIF by Semenza in 1995, William Kaelin was studying a gene involved in cancer called the von Hippel-Lindau gene, or VHL. His group, in collaboration with others, showed that cells lacking VHL had increased expression of hypoxia-inducible genes. Subsequently, Sir Peter Ratcliffe's group showed that VHL was necessary for HIF to be destroyed by the proteasome. This indicated that a key role for the VHL gene was to direct HIF to be destroyed under high oxygen conditions. However, we still didn't know how oxygen regulated this switch. Ratcliffe and Kaelin then simultaneously showed the way by demonstrating that an oxygen-dependent reaction seals HIF's fate in high oxygen conditions. When enough oxygen is around, two prolines in the HIF-1 alpha protein are hydroxylated. Hydroxylated HIF is then recognized by the VHL complex, which then targets HIF for destruction. To sum up, then, this elegant switch, which was elucidated by the work of this year's laureates, under low oxygen conditions, HIF is made, it accumulates in the nucleus, and that results in the induction of a wide variety of oxygen-sensitive genes. But when oxygen is present, effects of HIF range across almost every aspect of physiology, from metabolism to exercise, to embryogenesis, to immunity, and the changes wrought by altitude.